in finance.
They asked it differently, but yeah.
Yeah, they did ask it differently, but oh my gosh.
I'm actually. Are you're no longer doing it, ne? You guys don't do it. Become loyal. Yeah, they changed it.
What was talked about they will expenses, assets, and collections.
In finance.
Credit liabilities.
In finance. Woo! So please open one of your finance.
No. Let's leave that thing alone. That's a problem for another day. So, it's unfortunate the gentleman is not around right now. But what I just wanted to speak to here is, remember, your correlation is going to fall between, maybe actually using this is better. It's going to fall between -1 and +1. And there was the question of what if it's 0.5, whether positive or negative. That means there's a moderate relationship. Does it make sense? If you get to 0.3 on either side, that means it's a weak relationship, but there is a relationship. What happens when it's then 0? There's no correlation, there's no relationship. All over the show, yes, 100%. Okay? Are you now seeing, this is how you need to be interpreting your correlation coefficient. Okay. Does that answer what you are asking as well? Okay, right. So whenever you are close to 1, you know it's whether it's positive or negative, it's a strong relationship. Okay, but that's fine.
So the more it moves to 0, the more the linear thing
gets weaker and more scattered, as you're saying. Yes. Yeah. Okay, right. So the last thing that they ask us there on this question, or do I need to scroll up? Is it loading? The last thing that they ask us is they say compute the coefficient of determination and interpret your answer. What is the formula for the coefficient of determination? This one should not be, we should know from yesterday.
Isn't it that A plus B or something like that?
Nope.
Isn't it that formula?
Nope. It's exactly that. It's r squared times 100. So we're basically saying the coefficient that we've just calculated squared times 100. Okay. So what did we calculate again here? It's this, yes. You said 399.
Yeah, negative.
Yes, negative. 99 squared times 100. What do we get? Mm-hmm.
Minus 90, minus 0. Oh, 100. Okay.
This, by the way, you can never get a negative. Because the moment you say a negative times a negative, you get a? Yes. 96.883. 83. Okay. And this now is a percentage. Now, what is this coefficient of determination telling us? Yo, did I hit record? Oh, I did. You said that yesterday as well. I did, fortunately.
96.83 can account for.
Coefficient of determination.
The number of students can account for 96.83 of average marks. Or the highest average mark is 90.
Say again what you said. I didn't catch you.
I said the number of students can account for 96.83.
Okay.
Of the average marks.
Okay. Did you guys catch what she said?
No. Repeat. accounts for 96.83% of the average mark.
Okay. So basically, remember our number of students is our X variable, isn't it? Our independent. All right. And she's basically saying that our independent variable can account for 96.83% of your Y variable, your dependent variable, which is the average mark. All right. So we're basically saying that your your X variable can determine, all right, 96.80% of your Y variable. So which means that it's actually a very good independent variable in terms of predicting Y. Remember, we're using linear regression to try and predict or estimate what our average mark would be. Does that make sense? So now we know that, no. Number of students is a very good indicator. Okay, is it making sense? Okay, all right, so you guys need to know these different calculations, and also you need to understand what they mean for your study, because remember, they are just going to change the variables. They're not going to talk about average marks anymore, but still you must be able to run these different statistical techniques and then obviously answer or interpret. Okay, so this has been used. So now I just want us to go and do an easy exercise, and it's exercise 6. Exercise 6, and it is again a correlation test. And remember, correlation was saying, are these variables associated? Is there an existing relationship between the variables that we are obviously looking at? So here, with revision exercise 6, okay, and you'll see revision exercise 7 is the same in terms of it's also testing you guys on the Spearman's rank coefficient of correlation. So here in the question, they're saying two judges, Judge A and Judge B, have been asked to rank 10 different cakes in a baking contest, with the rank of 1 to be applied to their favorite cake through a rank of 10 for their least favorite cake. The results are given in the following table and then it says using Spearman's rank coefficient of correlation, determine the extent to which the judges agreed with one another regarding the quality of the cakes. Okay, so rank A is obviously Judge A's ranking, and then rank B is Judge B's ranking. So the first cake, Judge A has said it's 3. Maybe let me zoom in a little bit. Hopefully that's clearer. So for the first cake, Judge A has given it 3. For the second, for Judge B has given that same cake 7. Okay, but before we get into all of that, we want to further understand this Spearman's rank coefficient of correlation. Okay, right. So here again, we're trying to measure the strength and direction of the association between two ranking variables. All right. Now, unlike Pearson's correlation, which we just played around with, okay, which measures the linear relationships, okay, and this is what we were talking about earlier. Not everything has a linear relationship, okay, between continuous variables. Spearman's rank correlation assesses how well the relationship between two variables can be described using monotonic function, okay? To calculate Spearman's rho, the data points are first ranked in order of magnitude for each variable. The difference between the ranks for each pair of data points is then calculated, and these differences are used to compute the correlation coefficient. Okay, there's a key thing that I wanted to highlight here. Okay, again, much like your Pearson's, the coefficient is going to lie between -1 and +1. Okay, and did I not include it here? Okay, I don't think I included it here, but I'm very confident I thought I did. But the whole point is that here we are using Spearman's coefficient of correlation because it helps us to find out the correlation between variables that are ordinal. Remember, ordinal is where there's a ranking involved. Does that make sense? Okay. So I thought I had gotten that saved somewhere, but it appears that I haven't. So the formula is, as you can see there. And let me see, I never checked if you guys have this on your formula sheet. It's not there. But they're asking it here in question, revision question 7 and 6. Okay, well, let me teach you so that you don't say we never learned this thing that came in the exam or the test. Okay, but yeah, so that's the formula right there to calculate this Spearman's correlation coefficient. Okay, so as they highlighted, your first step is you need to get the rankings of both for all 10 cakes. So you guys quickly tell me, what was the first cake? I believe it was 7, eh? For Judge A. It was 3. Let's use this one. It was 3. You say, why is this thing? Why can't? Okay, I can write on it. Okay, 3. And for Judge B, 7. So the difference is obviously 3 minus 7, which will give you a -4. Yes. Then we go to the second cake. The second cake, what was the ranking for Judge A? Okay, maybe let's just do all the cakes. 8. Okay, all right, let's just do all for Judge A first. 1, 5, 8. Okay, and then going back to Judge B for the third cake. Uh-huh. 5. Okay, so we're getting this between all of these. Maybe we don't even need to write this out, or should we write it out? Basically saying 4 minus 8. Yeah, -8 here. Then this is 7, and this is 2, +2. Right. So now when you've got those differences, here, this last column is what we want. We want this last column, and you'll see now what we do with it. Oh, actually, let me not do this bit. Right. So we're squaring this difference. Can you see here? If you look here, it's di squared. We're calculating di over there. So 4 times 4 is obviously going to give you 16 again. 8 times 8 is 7 times 7 49.
49.
and 4. Okay. Then what you now need to do, let's go back to our formula and see. They want the sum of your squared differences. So what is the total here? So you did all of that just to get this. That's all we needed. Okay. So we come back up. Now we want to insert this into our formula. We have got, let's do this. Okay, so here we are saying RS, maybe let me use a different color this time. Is everything okay, my friend? Is everything? 6, okay, and then the sum. In fact, I don't need to rewrite that. Yes. We said it's 3, 1? Okay. Right? Then we said divided by, and we know is how many cakes do we have? Do we have 7? 10. 10 cakes, yes. Then so 10 squared here minus 1. Okay. So what then is our 0.92? Right. Is everybody getting that? Are we all getting the same answer?
Yes, we are.
Okay.
Yeah.
Okay. Right? So this is our answer. This is our answer. And how do we interpret this? Negative 0.2.
Strong negative linear relation between the x and y variables.
Okay. We interpret it the same basically as, yes. So a strong negative, well, it's not a linear relationship, remember. So we can't use, yeah. So, but a strong negative relationship between them. It's not linear, yes. Rankings. Okay. So we're basically, remember the two things we were assessing here was the judgments of the two different judges. We wanted to see, are they judging the same? Is there a connection between their judgments? And what we saw, the closer the differences are, the more, if let's say where we had -4, we had -1, that means that the difference is actually closer. Because it means that, for instance, where we have Judge A, he would have given a 6. So it would have been 6 minus 7. Does it make sense? So the closer those are, the closer those variables would be. So here we're saying, hey, these guys, they don't judge the same. Remember, because whenever we say negative, we're saying the direction they're in opposition. They are opposed. If it was positive, then we say, okay. And let's say if it was positive close to 1, then we would say, okay, these guys are same WhatsApp group. Is it making sense? Okay, I hope so. I hope so. All right, so that is your Spearmans. Just make sure you understand. You can see it's not that hectic. It's definitely doable.
So what learning unit is?
This is learning unit 4. Yeah. I don't know the chapter in the book. Yeah, because they flipped things all over the show. But guys, that is your learning unit 4. That is your learning unit 4. If you look at the questions in your work pack, you'll see that we've covered all the different ways that they can ask you linear programming or linear regression. So if you just practice, do more questions, also check on your interpretation, you'll be fine for linear regression. And then obviously when I see you tomorrow, we will, it's not tomorrow, it's Thursday, ne? We'll, huh? Really? I feel I need a break.